Okay, last question. It's only worth 6 marks, so we shouldn't be too quick, too slow to do. So it's question 9. Consider the function f defined by this thing here for x, a member of the real set, positive real set. The graph of f and the line y equals x intersect at point P. Find the x coordinate of P. Now, I reckon this is probably the fastest way to do it. I would grab a new page and create a graph, and I would make one function exactly as it says there, 90 e, not use that e, got to use this e to the negative 0.5x, and that's that. And then the next one is y equals x, so I'm going to go Control G to add a new one and go f of 2 of x equals x, like so. There's the point of intersection. Luckily, it's just on the screen, so I don't have to zoom in or zoom out. So I'm just going to go straight to Menu, Analyze Graph, point of intersection there. Go to the left and to the right of this boundary, and we can see the x-coordinate is 5.57. And unsurprisingly, the y-coordinate's the same. That's just 3 significant figures, so we're good to go. That's part A done. Now, if you look at the solution, you'll see the attempt to find the point of intersection. What I would possibly do if I wanted to confirm that I was going to get 2 marks for it is either draw that graph in, so literally just draw the axis, draw a graph, and then put it in, and then say by GDC, or you could set 90 e to the minus 0.5x equals x, therefore x equals, so you can show, that if both of these things are equal to each other, then x would have to be, in inverted commas, have to be 5.57. Something like that would be good enough, but just doing a quick sketch would be just as good as anything else. And you've already got it here, so you're good to go. I just do that. We can sort of see it a little bit better. Done. Okay, part B is a bit more tricky, and really probably, I don't think you can use your calculator very well for this one. Now, I'll tell you why. The line L has a gradient of -1. This is not the line L. This is just another straight line. Has a gradient of -1 and is a tangent. That's how I know it's a straight line, because tangents are straight lines. And is a tangent to the graph of f at the point Q. Find the exact coordinates of Q. Now, because of that word exact, it means that I can't really rely on my GDC, because my GDC works in approximates, really, at the end of the day. So not much we can do there. We have to do it exactly. So I'll show you with the mark scheme so you can sort of see how to do it. Ultimately, what this requires you to understand is a few things. What does the line L has a gradient of -1 mean? What does it mean that it's a tangent to the graph of f? And ultimately, connecting these dots together is what will get you the answer. It's a tangent to the graph, which means that the gradient of -1 of the line will be the same as the gradient, the instantaneous rate of change, the gradient at the point Q of f. What does that mean? Well, if the gradient is -1 at the point Q, then that means that we need to find the derivative of f in order to solve it. So again, I just wanted to show you that there's not a lot of calculator usage that you can do here, even though it feels very calculatory. You find the derivative, so using the onion rule, using the chain rule. So the derivative of minus 0.5x is minus 0.5. So 90 times minus a half is minus 45. And then the derivative of e to the something is just e to the something. So we're left with this. I might just zoom up so you can see it. So we're left with minus 45 e to the minus 0.5x. Set that equal to 1. And then you have to solve. And honestly, there's not much you can do because it asks for exact values. All you can do is divide both sides by minus 45 to get 1 on 45. Take the natural log of both sides and you'll get minus 0.5x equals ln 1 on 45. So you can see the solution here is ln 1 on 45. And minus 0.5 is actually minus 1 on 2. So multiply both sides by minus 2 and you will get minus 2 ln 1 on 45 as your solution. Why does this one work? Well, because 1 on 45 is 45 to the -1, and then there's that log rule which says powers can go in front. So the -1 goes in front, and -1 times -2 is 2. So you end up with 2 ln 45 as probably the simplest possible value, like so. Then if you need to work out the Q coordinate, which you do, you can substitute that in. So I guess you can use your calculator to see how you go with that maybe. So you can go back to the original equation, not this one. That's the derivative. So back to the original equation, and you can go, well, I've actually already got it in here, haven't I? So I've got f1 of x already in here. So all I have to do is I just have to go to my page 1 and go f1 of 2 ln 45. Oops, got to put it in brackets, it doesn't like it. f1 of 2 ln 45, and you get the value 2 out of it. So you go, oh, cool, it's just 2, and then you're done. Okay, so, your GDC does become useful because you've used it across the questions. And so that's kind of good. That's it for this. The question did keep on going, but it was stuff that we hadn't covered at that point, so that's why it's not in. But nevertheless, there you go. That's based upon everything we did in that paper. Now, listen, if there are questions that you would like to see and understand how to do it, so question 8, for example, was missing. Question 1 was missing. There may have been others as well. Just feel free to email me and ask me to do those questions. If you want me to do them, happy to do them. What I haven't covered is a statistical question where you might have to put a table in. I haven't covered any trigonometry function questions that you might be asked to do. I also haven't covered any thing of the common ones, probability distributions as well. So none of those I have done, but I'm happy to create a video, calculate a video on any of those topics. Just let me know and I'll do so. But I'll leave this video right here.